guys, my name is Rohan Singh. I'm an infrastructure engineer at Spotify, and I just wanted to talk to you guys about a little bit about what we're using Docker for at Spotify. So to give you an idea, I think most people in this room probably know what Spotify is. This is kind of humorous to me. When I moved to Sweden a couple of years ago, nobody in the States knew what it was, and now when I ask people, they roll their eyes like, yes, of course I know what it is. But here's just some numbers if you're interested. We have lots of music and users, so yeah. More relevant though, our backend is, we use a service-oriented infrastructure, so we have tons of little services that each do one thing and hopefully do it well. In reality, some services are huge and do more than one thing, and some services do things badly, but that's another story. But to give you an idea, some of the services we have are like a playlist service or a search service or a metadata service or recommendations or anything like that. And each one of these services is owned by a distinct squad, like a group of developers who are deploying it to a bunch of servers around the world in 4 different sites. And we're at the point now where we have over 250 servers per ops engineer, physical machines, and it's getting tough to handle. So Relate IQ kind of showed you that photo of devs being kind of upset trying to run all the services that have accumulated on one dev machine. We don't even have, I can't even imagine trying to do that at Spotify. That would, it would blow my mind. But that's where I want to be eventually, but we're not there. So to give you more of an idea of some of the challenges we have, when we try to deploy new services, we have to basically requisition new hardware or get hardware configured because each one of these services is deployed on physical machines around the world. The corollary of this is that our hardware utilization is pretty low because any service, we want to leave some room of some overhead for it to grow. And we're just not utilizing a lot of hardware, but we have a lot of it. Another issue we have is that it's really unwieldy to manage this huge number of machines. Even though we use Puppet for configuration, one of the most common things we do, since we use Debian packaging for all of our services, is to go ahead and upgrade the Debian packages on any given set of machines to upgrade to a new version of a service. This usually involves developers SSHing in or using something like Fabric to SSH in and do apt-get update and apt-get upgrade across however many machines their service is on. You can imagine this fails a lot, and when it fails, you don't necessarily know where it's failing. And this results in the next problem, which is that machines get denormalized pretty easily. When you have devs SSHing in and messing with things, nobody really puts things back, or hopefully they do, but we can't know for sure right now that all our machines are in kind of a consistent state. But anyways, that gives you an idea of some of the issues we have and why we started looking at how we could make our deployments more repeatable and quicker and less painful for our future developers. So the first thing we did before even going with Docker is to get really familiar with LXC. We were pretty sure we wanted some sort of container type thing because we didn't want to deal with the overhead of virtual machines. We have an internal test environment that uses virtual machines, and it takes, even though it's gotten a lot better, it takes a while for us to spin up these VMs, and it's just not something we wanted to deal with. So getting really familiar with LXC, we were actually skeptical at first about Docker because, well, LXC, it works, why add another dependency? So we started experimenting with that this summer. What we found though is when trying to use LXC to actually deploy real stuff in test and mess with it, we ended up writing small scripts and thinking things like, oh, hey, if we were using Docker, this is already provided and we could just do that. And eventually we were doing something like building our own hacky version of Docker Lite, at which point it became pretty obvious that Docker was the way to go. So we decided to go down that road. And so far what we've done is build a kind of internal VM offering for our devs within Spotify to mess with Docker. That was a fun project because internally we use Debian squeeze on all of our machines. We, at first, were experimenting with LXC on squeeze. if you tried to run Docker on Squeeze, at least as of a couple months ago, it wasn't a lot of fun. So our long-term vision is to use Ubuntu everywhere, but this is the first project where we actually had to do that, which involved porting a lot of our stuff, which had a lot of weird dependencies and so forth. So that was fun. The next thing we did is start to build these base images that we want our feature teams to use, so that if you have a Java service as Spotify, you can just say from Spotify Squeeze Java base, or from Spotify Python base if you have a Python service, and then just inject your own code for your service, whatever your package is, or your jar or whatever, and just run. And then we started integrating this into our build pipeline. So we have Team City, and what we can do now is with our Team City builds, when any service that has a Docker file gets uploaded, it gets built as a Docker image and pushed to our own private repository where any machine can pull it down. And then kind of as a stretch goal, we actually ignored all the warning labels and went ahead and actually deployed a container into production and started throwing real production traffic at it for our service. It's called metadata, and it serves up all the metadata for, when you look at a page that has kind of like, say, an album, it's like, what's the name of the album, what are the tracks in it, and stuff like that. We started sending production traffic to it as of a couple months ago, just to see. We wanted to get like this canary of, is anything going to go crazy? Is anything going to go wrong? And it's actually been running continually for weeks and weeks and weeks, and no problems so far. So this is only part of the way. Some of the future stuff we have is we're working internally on a tool called Helios, which is, it's kind of similar to what a lot of people in the community are working on, is something on top of Docker to be able to coordinate all of our Docker hosts and push out containers or images and run containers across all of our hosts without worrying about, specifically where they're going, or being able to say specifically where they go and stuff like that. Kind of a higher level orchestration framework. The other thing we're doing is using Docker to make our build pipeline super fast. One thing we do with our builds, building these Debian packages, is you can specify different build configurations. Say you're building for AMD 64, or maybe you're actually building for Precise or Squeeze or whatever. And then our build servers set up a CH root and do a big bootstrap process, which involves installing a bunch of Debian packages, and it can take a couple minutes before we're even ready to build. So if you have a similar kind of build process, you can get around that entirely by just making Docker images of each of your build configurations, and then you just run that container and then do your build within it. Running the container takes, it only takes a few milliseconds to start up, right? And then the big kind of thing we have internally is doing this kind of internal evangelism to educate each of our feature teams on why do you want to use Docker, putting together videos and tools to help people get this idea of, even though we have all these pretty autonomous teams that can build services however they want, giving them the idea that, if you use Docker, you get all these benefits, you don't have to worry about building these physical machines out, and you can do all this other cool stuff. So yeah, that's just kind of a little overview of what we're doing. A lot of this stuff, Helios especially, we're building it with the plan to open source eventually, so you should see it on our GitHub. Other stuff you can, there's a link to our labs blog. You can go monitor our progress on various projects. And that's pretty much it. Any questions? So the question is, why did we want to go with Docker or Linux containers instead of virtualization? A part of it was definitely the provisioning times. We've had a lot of issues with our test environment in terms of those provisioning times, and with using Docker, what we can do is actually not only have a quick provisioning time for our production containers, but we can take those containers and do things like now run integration tests against them during the build process and not have to worry about spinning up a VM and so forth. Another reason was because of using AUFS or whatever file system we end up using in the end. Each one of these containers is pretty tiny, and we can actually feasibly ship them around to all of our sites without having to ship these giant VM packages. That was a big consideration, actually. So right now, our vision is definitely to have that kind of stuff. We've just started with this project in the last month. So currently our MVP is to be able to not even support multi-tenancy, just say, I want to run this container on this machine. And we'll start from there, and then we'll add multi-tenancy, and we'll add scheduling perhaps, maybe auto scaling, maybe this, maybe that. Usually the way we do these things organizationally is the team that I'm on that's building this is our service infrastructure team. So a lot of times we'll like create these minimal viable products and then go out to our feature squads that actually use them and ask them, what's going to make your lives easier? What do you want? And that's kind of how we're approaching this. We've signed up a couple teams who actually want to use it in production, and we'll take their feedback and go from there. All right, cool. Thanks, guys.